Hello, welcome back to BlenderSushi. I'm gonna do another live nodding. In this video, I'm gonna try something to do something that's a little bit more technical. The other day, we have looked at how we could create some of text effects using animation nodes. Today, we're gonna do just a simple text effects, but the way we control the animations is slightly different. So instead of um, putting all the animation controls inside animation nodes, we're gonna try to set it up so that the animators can have more control in 3D view. Perhaps I have already shown you this a couple of times before, maybe using Vertex or maybe using Blender drivers, but I'll do it again anyway. And we're gonna use text as our context. Let's get started. So let's create a text. Let's center our text. We can leave it just on the ground like that. Doesn't matter. Let's get text effects. I don't know. It can be anything. So let's go to animation nodes. Create a node setup. And now we're gonna use text object object separate, but we're gonna also use the text object output just in case we're gonna change this text. So hello, you just leave it like that. Let's source this. Wait, let me turn off always. Turn on this tree. Now let's source this guy and then just update it. Now I'm gonna, let's see what we're gonna do. Firstly, set the origin to geometry and maybe hide the relationship lines. And yeah, so here we're gonna control the text object output. Actually it's more like object transform output, and for each object we're gonna just okay, let's say the effect is like this. All the text is like backward like that, but it's gonna turn one by one into like a settle position. But we're gonna do that using DynamicPaint. So text effects, advanced. We're gonna use DynamicPaint. How are we gonna do that? First of all, I'm gonna turn this guy. I'm gonna have like a points to represent each and every letter, every character. And I'm gonna turn it into a canvas for DynamicPaint, and then I'm gonna use probably like a cube as our brush to trigger the effect. So may seem complex, but then not really. So I'm gonna show you. Okay, let's do it. Okay, this guy is an object now, but we don't have, we cannot use it as canvas object. I want a single mask to represent each and every letter. So in order to do that, I think we can use the mask object output, and then there's a handy option here. It's called vertices, and we can just plug in the vertices data in there, but we need a we need the center of each object, which we can grab using object transform input. So here, let's try. So this guy goes in there. So we have object transform output here, which will control our each and every letter, but we have object transform input here that can output the points for as a canvas. Let's see, create a vector. Let's generate a vector list. Let's plug in the location. Now we have that guy plugged in there. Create a new target, and the vertex amounts are not equal. Vertex amount are not equal. That's interesting. How many vertices actually goes in there? Let's check real quick. Debug loop and check the location data. Oh, it's not really looping. Always 1, 2, 3, 4, 5. Where's the target object? Outliner. Vertex amounts are not equal. Very interesting. Maybe we cannot just do it directly. We need a separate loop, I think. So that's alright. Create another loop. So with this loop, we're gonna find the center of each object. Generate a vector list, and each object transform input. Let's try this. Maybe it's a bug. It's probably a bug. So we cannot use vertices, unfortunately. So we just use a mesh data. And now it's actually working. So yeah, unfortunately, yeah, that's weird. So sorry, I have to do this twice. Transform input, location, output vector goes into that guy. So we can do it like this. Anyhow, we have now the target, and the target, this object called target, is the center points of every letters. We can use it as our canvas. DynamicPaint canvas, okay, and it's gonna be the canvas is gonna take the weight, vertex weight from the brush, and it's gonna output this DP weight. We turn it on. Okay, and I think we are ready to go. Let's go to frame 1. This is our brush. The brush can be left as it is. Maybe mesh volume and proximity. That's right. Let's see how it goes. When the brush goes into the canvas, like all these points, it's supposed to trigger. It's kind of giving a weight value into each and every point. Let's see if that's actually working. So I'm gonna grab the mesh data of this object and mesh data and just grab it from that guy. Turn on use modifier. Make sure you turn on use modifier, because DynamicPaint is actually a modifier. If you don't have it, it's not gonna have any of the weighting. And now we need to loop the vertices. Tab W, loop through vertices, and then here let's observe our vertex. For our vertex, let's have a look at the group weight output. Check loop debug loop. Okay, so we need to calculate every frame. So if I drag this guy, so it has this proximity, dynamic proximity as well. So you can see the value going up and down. Let me turn off the proximity and just use mesh volume. It's apparently just like 0, 0, 0. What if it's okay? I just leave it like that. You may notice the value goes up and then goes down again. DynamicPaint Vertex Weight painting will work if we have the timeline running and then we actually paint over it. Now we can see the value goes up until it's reaching almost 1. That's actually kind of behavior that we want. So that's how we could trigger our animations. We have everything ready actually. With the Vertex Weight, actually per object mesh, it can store multiple vertex weight. What I mean is you can have like a multiple here. So that's why this is like a list, but you only need to use the first value in the list. So we need to use get element, get item, element, get list element, and just get index 0, the first value. Okay, and we're gonna use that to trigger our animation. So how many loops do we have so far? So the first one, get centers of every object, so we don't animate it right there. Here we actually have the trigger effects. Okay, and we could actually animate our object right here. Alright, so now what's we gonna do? Let's create another object list of slot right here, object list, and then we plug this guy into that loop, and fingers crossed, I think everything is gonna work as planned. This is triggering. So that's our objects. We're gonna transform our object. And this is gonna be, I think we will need the initial rotations, kind of initial transform. So we're gonna use the ID, object ID key, and then grab our objects and then get the transformations, and maybe turn on locations, plug in the rotation initial location, so it's settling the rotations. Now with the rotations, I will let's see, we're gonna use a Euler mix Euler, yeah, I think that's what we need. The rotations can be random, or for now I'm just gonna rotate this guy slightly. Let me test it if it's working or not. Okay, it's working. It's vector 1. It should be 0, 0, 0. When it says vector is 0, this guy is like rotated 180. Now let's set up the triggering thing. We know that the group weight for the vertex is gonna outputting this value from 0 to 1, right? So all we need to do is just plug that value into the vector. So now if we reset everything, you see the letter is all facing backward. Now if I play back our animations and then slowly moving our brush, you see how our text is magically turning itself. Although that guy, the last one, doesn't seem to rotate fully. That's because the value of weighting is not exactly 1. We can fix that using map range. So the value will actually hit 1. So plug that in there. Input max is going to be 0.95, for example, but the output min and max is going to be 0 and 1. So now yeah, maybe even 0.9. Let's try again. There you go. So the effect is triggering one by one. Now we are good. So that's pretty much the setup. Let's test it using a different word. If everything works as planned, we can change the text into anything. So say happy Sunday. Update the text. Happy Sunday is working. Reset everything and then play it back. And our text is rotating one by one. There's that guy that doesn't seem to hit a 100% 1, which is pretty interesting. Maybe then we can remap this guy to 0.8. So there's a kind of hiccup here and there, but that's alright. We have a lot of control actually by doing it like this. Maybe this maybe we need to bake the dynamic paints eventually, so we cannot just play it like this, but this is gonna work. Let's see if we actually use a random Euler rotation, Euler, random Euler, and Plug that in there. Plug Euler. So before it starts, everything is kind of rotating like that all over the place. But if I play it back, now everything's settled. Yes. Probably because it's a bit jumpy. If I bake it or use a subframe, it's gonna give a more accurate result. So I'm selecting the canvas. Maybe I turn on anti-aliasing or substep fade. We can make it so that it's fading after a certain period of time. So it started like random like that, and then I go through, and then each character is gonna go back to original random position. Yes, so maybe I'll make it more 3D. So the snail size extruded 0.034, update it. Now all the text 3D. Let's trigger it. You can see the value here. It goes up and goes down again. So let's get back to the target. Turn off fade. Let me check if everything is correct. Mass volume and proximity, object center. Maybe just proximity will do it as well. Yeah, this is actually looking more accurate for the snail at least. To do it, if I do it really slowly, yeah, I think that's just the way it's calculating. We need to bake it or do it slowly so it's gonna work. Let me try again. I mean, we could just plug in like a random text, randomize or characters. So randomize. Actually, don't do that. Let's do it with a text block. Let's create another text editor here. New. Grab our text. What are we gonna write? Let's see. Test effects animation triggered using DynamicPaint. This is Blender and animation nodes. And let's use a text block reader. Grab our text, plug that in there, update. I should have saved this because it might crash. Okay, how many do we have now? File save as. Okay, we have all those bunch of text Let's increase our simulation time to 1000, and same thing with a dynamic paint, increase it to 1000. And now let's go to 3D view full, and then turn off only render. We have our brush here, turn off relationship lines. We have a jumble up text, but you know, if you give this to animators, they will, and just explain a little bit how it works, they will be able to use it. This should be our timeline. So in order for this to work, you need to have the playback running, because this is a simulation, it's a dynamic paint. What I'm thinking to do is maybe kind of a way to trigger these effects using dynamic paint, like auto spreading. The auto spreading is only working for vertex coloring, I believe. Well, we might need to bake the textures and then use that with displace modifier to do the triggering for the vertex weight. But you know, I think this is quite powerful, even though we are doing it simply just for text effects. But in fact, you can do a lot with it, and you can have, like I said, you can have multiple vertex weight for each objects. So if we have multiple brush, maybe a red brush give a red color, and blue brush gonna give blue color, and so on. It's gonna actually work just very intuitively. So yeah, I remember a few years ago I tried to do this using Blender's drivers, or even like a Py driver using Python. It's a little bit much more complex compared to just using animation nodes and dynamic paint. Yeah, so there you go, another technique for you that you might use in your project. Hopefully you find this tutorial useful. You can feel free to leave comments and like, and please subscribe to the channel if you want this to continue on. Yeah, thank you so much. Hopefully you find this useful.